Hello and welcome to today's EduSet presentations on TCP IP. Since TCP IP is a very broad topic, I will be simply talking about only one subtopic of it, that is called IP addressing schemes. But before we go further, before we go into the full discussions, let me just remind you that when we talk about computer network course, we always start with two reference models. One is what we call them OSI model, and second is called the TCP IP model. And let me give you the basic diagram of the TCP IP models to understand what is the discussion, in what directions our discussions will take place. So this is our TCP IP model. You know that TCP IP is a standard protocol for the internet. When we work on the internet, when we surf the internet, when we send email, whatever we do on the internet, the behind the scene is the TCP IP protocol. So let me just draw this TCP IP reference model. On the top, just like in the OSI model, we have applications layer. So there is applications layer, because just like OSI model, TCP IP also designed in hierarchical model, and on the top it is the applications layer, and there are standard protocols running to support different type of applications. Is called what we call them. You know that there is a telnet protocol, there is a FTP protocol, file transfer protocol. Then we have the SMTP protocol. When we send the email, the standard protocol is SMTP. Then we have the DNS and so on. So these are the standard protocols running to on the top of it to support different type of applications. Then in the OSI model, we have a presentations layer, but in the TCP IP, this is called presentations layer. Then we have a sessions layer. But in the TCP IP model, right now we are talking about TCP IP model. I told you in the beginning that TCP IP is a standard protocol for the internet. It defines the backbone of the internet. It is a packet switch networks. So on the top is the applications layer protocol. Then we have a presentations and session in the OSI model, but in the TCP IP there is no presentations layer, there is no sessions layer. So these two layers are missing in the TCP IP, but it is there into the OSI model. Then we have a transport layer protocol. So it's just like whenever you design a complex systems, complex software, we always design into a layered structure. Rather than putting them everything into one monolithic structure, we define them into several layered model, so that if there is a problem with a particular layer, we can rectify to only that one, and the rest of these sub layers or rest of the parts of the software are intact. So there is transport layer. Now transport layer, we have a two protocol called the TCP and the UDP protocol. These are the standard protocols are there. And then we have a internet called internet layer or network layer, in what we call them in the OSI model, but in the TCP it is called internet layer, and the standard protocol is IP. So IP stands for internet protocol, TCP stands for the transmission control protocol, and so user datagram protocol. So IP, our discussion is around this one. So today we are going to talk about different IP addressing schemes. So this is IP, and here is the host to networks, and there are large number of protocols. In fact, TCP IP does not specify a particular protocol, but standardizes many such protocols developed in different models. So our discussion is now this one. We are going to talk about different addressing mechanisms. It's just like a telephone networks. Since every telephone has got some address, then only you talk to someone else, or if you want to talk to someone else through telephone or through mobile, you must know his number. So everyone must get some unique number. Similarly, when you send some data to someone, let's say you are sending email or doing the FTP or doing the telnet, you have to know the person whom you are sending this mail or whatever you are doing them. So in computer network or in the internet, each machine or each device, what we call them, must have some unique address. Now how this addressing is done, this is our discussion today. So you know that the old version is called IPv4. Now internet is evolving, so is this internet protocol called IP. The old version is IPv4 and the new version is IPv6. Our discussion is around IPv4. But to understand IPv6, you have to understand the architecture of IPv4. So we will confine our discussion to only IPv4, means version 4. And in computer, now that this basically the each device, as I told you earlier, the network has a unique address, and what we call then in computer jargon or internet jargon, it's called IP address. So if you have got a machine and you are connected with the internet, you must be given some IP address, and the size of the IP address is what we call them 32-bit. In computer, you must know this is called 32-bit. So the size of IP address is 32-bit. I think so you understand what the discussion is going about. We are talking about IP addressing schemes, and the size of the IP is 32-bit. Just like you have a telephone number 6-digit or 7-digit, or if you have a mobile, you have a 9-digit, and so on. Similarly, in computers, every device which is connected with the internet, they must have unique address, and what we call them in computer jargon is called IP address, and the size of the IP is 32-bit, because in binary you have a bit, byte, gigabyte, megabyte, and so on, kilobyte. So we'll talk about how the addressing takes place in internet. So the first thing that is very much important, you have to understand that every device in the internet must have unique address, and the size of address is 32-bit. This is what we have discussed so far. And so you have a, just like in telephone, few digits are reserved for the area code. That is, suppose that if I have to make a call to let's say Delhi from somewhere else, then 011 and something like this. So each telephone number also has some area code like south, north, east and west and so on. Similarly, when you define the 32-bit size of the internet address, also it is hierarchical. Some bits are for something, some bits are meant for something else, and this is what we are going to discuss now. So this is the, so each machine, you are all connected to a machine. If you want to connect to the internet, this machine must have some 32-bit IP address. Now how this scheme is structured? It is structured in a hierarchical fashion. In fact, briefly, it is a 3 parts. First is called what type of class. In telephone you don't have, but here you have different type of classes of address scheme. So first few bits are basically called class type. What type of address class you have? There are different type of addresses. One depends upon the organization or size of organizations you want. So you have to specify for particular type of class of address which you want to assign to your machine. For example, so it is your class type, and there are different classes in this one class type. There's only few 2 or 3 bit, and then you have a called the second part of the IP address is called net ID, and the last one is called host ID. The host ID is what your machine is. Net ID in which organizations you are connected to. So for example, you have certain organizations like our university has 700 machines. Now each machine has got a unique address, but they all might be connected to the same net ID. So net ID might be organizations and something like this. So bigger organizations have many host IDs, but they might have a single host ID. So the host ID is the name of the organizations or type of network or type of what we'll call them the internet subscriber. For example, in Delhi I can have a net from the Airtel or from MTNL or from VSNL and something like this. So the organization which provides the net, that it also must have some address. So whom you subscribe, someone provides you very cheap, then you subscribe to that one. So there are many gateways are there which supports the internet services. So net ID refers to the organization which supports the internet address or the organization in which you are working, and this gives you the part of the address of your machine. So now, so what we discussed now, the 3 component of your IP address. One is what we call them class, second is net ID, and third is called host ID. Again, once again, repeat, net ID is names to the refers to organizations, where the host ID refers to your own machine's address, and then the first one is the type of class, depends upon how much bigger organizations it has. So the just like for example, in telephone you have a telephone number 2508931. So this is one way to specify the number. In computers we have a different notations to specify the address, right? So I mean, discussion is already clear to you that everywhere, just like you have a home address, you have a telephone address, you have a mobile address, similarly each machine has some address. Now we also define the structure of this one. Now how notations is specified? So there are three types of notations are there, and three ways I can specify the address of your machine or IP address in more technical sense. So the notations, right now we are discussing now notations. How many different type of notations we have? Three types of notations we have. One is called binary notations. Binary notations, which basically binary means 1 0. In decimal we have 0, 1, 2, 3, 4, 5, 6, 8, 9. But in binary, computers work with only 2 digits, either 0 or 1 or combinations of it. So I can specify 32-bit as through binary notations form. The second one is called the decimal dotted notation, just like the way you define your mobile address, and decimal is something you remember always. If I give your telephone number into binary, it will be very, very difficult for you to remember. So the second, for remember or for compactness, rather than specifying 32-bit, you can have specify it in much more compact fashion, and for that there are two different notations are there. One is called decimal dotted notations. Decimal dotted notations, and the third one is called hexadecimal. In computers we have different type of notation, different type of systems we work with it. We can work with binary, we can work with hexadecimal. In binary the base is 2. In decimal, which we use most of the time in our day-to-day activities, we use a decimal number where base is 10. In hexadecimal the base is 16. We have octal system also where base is 8. So but we confine to only 3: decimal dotted notations and hexadecimal notations. For example, if I write something like this, your machine, although you work with your machine, but you must know what is IP address, for example, or how IP address is specified. So I can specify the one. This is one example I can see. So if I have a 32-bit, it means that I have to specify 4 bytes. So 8 bits means 1 byte. That is, you must have learned in your computers courses now. So I have to define 4 bytes, or sometimes we call 4 octets. 1 byte is 1 octet also it is called, and 1 byte comprises 8 bits. So this is my first 1, 2, 3, 4, 5, 6, 7, 8, something like this. Then I am defining something. This is the IP address of a particular machine. I have defined 1. This is my 1 octet or 1 byte. 1, 2, 3, 4, 5, 6, 7, 8. I think this one, up to this one. 3, 6 to 8. This is one chunk. This is the second chunk. This is my third chunk, and this is the fourth chunk. So one way I can specify my address. How easy to remember your mobile phone? Just you remember. But can you remember someone's mobile phone in this form? It's very, very difficult for anyone to remember it. Even your telephone number, someone gives you this one, also very, very difficult. Some organizations you have a interconnect, what we call it, intercom number, 2 digit or 3 digit. If that also is given into the binary, it will be very, very difficult for anyone to remember, because remembering in 0 and 1s is a very, very difficult task. So it has to better to remember into the decimal form, which we use 10, 15, 20, 30, 500, 600. So this can be converted into 128. If you convert them into the decimal form, this is where we convert it. This is the 128, and then we put dot. That is why they call it decimal dotted notations. 128, it becomes 15. This is this is 128. This is 15. If you convert binary, this is you'll get. This is your 7, and this is called perhaps 3. Something like this. This way also is remembered. So sometimes when you open your computer, you will get this type of number, 4 numbers, and each number is separated by a dot, and that is your IP address of your machine. So this is where we do. So we have we converted now. One is this one, binary. Second is the decimal number. Now we'll go to the third notations. But anyway, before let's say conceptualize, so that we should not do any error. In computer science, what we discuss is that you have to do more problem solving rather than remembering the facts. It's not a history or any other subject. You have to solve few problems. For example, I'm just trying to answer few queries. Question number 1. Find the error, if any, in the following IP address. This is the questions I am trying to answer now. Find the error in the following IP address. So I'm now writing some IP address, and I'm asking whether it is a correct IP address or not. So this way also we learn how to define the correct IP address. For example, I'm writing 121.50.040.70. This is another IP address. Now the question is, what is the error? Where is the error in this one? The error is here. This is error. When you define the IP address or internet address of your machine, it should not start with leading 0. It should not have any 0 at all. So the no IP address number will have a starting letter or starting digit as a 0. So always remember this one. So this is first thing. So this is one error. If I remove this one, then it will be correct. The second one, if I am writing like this, 200 into .30.299.60. So now dot 18. Now what is the error here? Where is the error in this one? I have defined first byte, I have defined second byte, I have defined the third byte, I have defined fourth byte, I have defined fifth byte. It is correct or not? It is not correct. What is wrong?
It has 32 bits, so 18 is the fifth one. 1 bit include 8 bytes include 1 bit include 8 bytes. So the fifth one should be erased. Then the error would be removed.
Correct. So correct, because you have 32 bits. So 32 bit means only 4 bytes. Only 4 bytes. You should not have fifth bytes. Here what we have written, this is the first byte, this is the second byte, this is the third byte, this is this one. So IP address does not support. It does not support more than 32 bits. In 32 bit you will get only 4 bytes. So the last one or any one might be the error. So fifth byte is not permissible in the IP address unless we extend the size of IP, which is going to take place in the next versions of IP called IP version 6 and so on. But right now not permitted, only remain confined to 32 bits now. Just like your telephone number, 6 digits initially. Unless they install something new and expand it, then only it can increase now. Now the third is, I am just writing the third. Now try to find out where. Now 75.45.299.14. Where is the error? Where is the error? The error is here, because the maximum with 8 bits you can have maximum 255 or 256, 0 to 255. So this is the range with 8 bit. You cannot have 290, what we call 299. Maximum you can go from 0 to 255. So this again is a wrong translations from the binary to decimal, because the range is 0. Each byte will not exceed more than 255. So it has to be confined to 0 to 255. So again here is the error. The last one, D, or fourth one. something like this. Where is the error? Just look at it and just give me where is the error here. Who will tell me?
Sir, these are in the binary forms, 110. If it is in binary form, then it must be in binary form in continuation. And 5 and 50 and 40 is the error. But if it is in the other form, then binary form is the wrong form.
So basically, correct. I think is the correct answer. It should be confined to only one type of notation. Either it be in binary, or it be in decimal, or it be hexadecimal notations. It cannot be mixed. So here this is the error. Okay, this is the error because you have mixed both. There is a one byte, first byte is in binary, the second byte is in your decimal, third byte in decimal, and something like this. So again correct. So basically this is the way we define the what we'll call them the notation. The last one is called hexadecimal notations now. Now hexadecimal notations, you know that each hexadecimal is only 4 bits. So we have a hexadecimal notations. Now each hexadecimal digit is a 4 bits. And this means that 32-bit addresses has 8 hexadecimal digits. If you talk about decimal, then we have only 4 octets we define. But if you are talking in hexadecimal number, then you require how many? You require 8 hexadecimal value you require, because with 4 digits you can have 1 hexadecimal, 4 bits you can have 1 hexadecimal. So for example, something like this. Let's say I've defined this way number. 3611, then something like this. If I can define, so I have to define 1 hexadecimal. I have to pick up from the left side to the right side bit by bit. This is 4 bits, 1 chunk. So this is 1 hexadecimal notation. This will be a second hexadecimal notation. This will be third hexadecimal notation. This will be 4th hexadecimal notation. In something like I can just put like this one. So this is what is hexadecimal. Again 8. In hexadecimal, how it moves from 0 to 9. Then how hexadecimal notation is specified. 0 to 9 just like a decimal. This 10 is your A. 11 is your B. 12 is your C, 13 is your D, 14 is your E, and 15 is your F. So for example, if I do something like this, just for your understanding, this is my 8 hexadecimal, first 4 digit 8, because this is 8, this is 15. So I will define what I will write, F. 15 is your F, 8F. This is 8 and plus 2, 10. 10 is my A. This way I will define my, so how many hexadecimal I will have? 8 hexadecimal notation, and each hexadecimal notation will comprise of this one. So this way, now there are 2 addressing schemes here. There are 2 addressing schemes. So far I have given you notations, binary notation, hexadecimal notations, and this notation. Now the 2 types of addressing schemes we talked about, addressing schemes. The first is called classful addressing schemes, and the second is classless. Today we'll talk about simply classful, and next time we'll talk about classless. Now classful addressing means that the whole address space is divided into 5 classes. In the beginning I had told you that if you look at the IP structure, then the first is class type. Remember first diagram, class type. The second one is called host ID, and the third one is called net ID. So there are number of different classes are there, and each one varies from another one in terms of number of hosts, number of nets, and so on. So basically we'll talk about class 1, and there are different type of classes are there: class A, class B, class C, class D, and class E. Don't get confused with hexadecimal notations. This is something different. We are not talking about notation, but we are talking about type of classes which we have. So A, B, C, D, E, these are this one now, and you can easily identify when you see this, when you see your IP address on your machine, you can easily identify which class you belong to or which class your IP address belongs to by simply reading 2-3 digits in the beginning of your byte or the first byte. Just read first or 2-3 bits, you will able to identify which class your IP address will belong to. Let's say for example, class A. Class A, the first bit should be 0, means your how many bytes you have, byte way, and first byte, second byte, third byte, fourth byte. So in first byte the first bit is 0, it is a class A. So I will just write class A, the first bit is 0, it should be. In class B, you have the first bit 1 and the second bit must be 0. So this way we are defining class A, first bit is 0, class B, the first bit is 1 and second bit must be 0. In class C, we have 11110. Please note down, we will ask the questions now. So the third is class C address. Depending upon, some organizations want very big organizations, one can go for class A. The less organizations, smaller organizations or less bigger organizations might go for B, C, D. But if the very large organization where hundreds of thousands of people are working and there are hundreds of thousands of machines are there, the different departments, the different groups are there, then in that they can go. But in most of the cases class A is vested. But otherwise, to understand conceptually, this is for use for very large size of this one. So class A, first bit is 0. In class B, what we discussed, first bit is 1 and second bit is 0. In class C, this is used for first 3 bits are 1s and 0. No, class C, sorry, the class C is this one, 2 bits are 1s and this one. In D, something like 0, class E, like this. So this way one can easily identify which class you have, this one now. Let's try to solve few problems so that you understand. I am just writing the IP address and you tell me which class it belongs to so that you can understand. So now, based on this exercise, now what we are trying to do is, we'll write few classes, IP addresses. You tell me which class this IP address belongs to. I am not concerned with the rest of the bits, because with only seeing first few bits you are able to identify which class it belongs to. Then we have a, let's say something like this. Now where it belongs to, let's start with first bit 0.
Yes, sir.
I will take some other call. This one belongs to A. Because why it belongs to A? Because this, it is starting with 0. And now we have 110.
It belongs to C. Because
It belongs to C.
110 as the first digit.
Correct. It belongs to C because just see here now, first 3 bits is 110. So now this is your A. This is A. This is your C. What about 101? Next sub.
Sir, there is B, sir.
This is B. Why? Because this is first bit is 1 and second bit is 0. So this is B. And what about this one now?
Sir, it is E.
It is E because all are 1s. So this way when you display, when you open your system, most of the time they will be given you the IP address of your machine, and by this one you can easily identify which IP class your machine belongs to. Now so the one way to identify is by seeing the first bit. But the another way to identify that is more appropriate, that you have to know, but for that of course you have to understand the binaries and decimal notations very quickly. Then you can easily identify it like this. Means one way to identify which class you belongs to, you have to understand the binary notations. The second way to understand which class you belong to, you have to understand the decimal notations also. So just now what I'm trying to do is This one you have to remember or you have to calculate yourself very quickly. The class A, this is my first byte. Right now the discussion is how to identify that which machines and which class your machine belongs to in the internet. So just by seeing the first byte, you can easily do either into the binary, either it is written into the binary notations or it is written into decimal dotted notation. Now binary notations exercise already we have completed. Now we'll work with the decimal dotted notations. So for example, I'm just writing class A. The class A range in decimal notations goes from 0 to 127. So if your decimal notations comes on your systems, most probably it comes as a decimal notations on your machine, IP, whereas IP address is concerned. So you should know that the decimal notations class A range is first byte from 0 to 127, because just you can easily calculate, because you have 8 bits in the first byte and first bit is 0, so only remaining is 7 bits. So 2 to power 7 is 128. But from 0 to 127, is there something like this? So the class A is 0 to 127, the class B range is 128 to 191. Only first byte you have to see, just ignore the third, second, third, fourth. The class C is from 192 to 223, class D 224 to 239, and then class E from 240 to 255. So this is what the range is, where decimal notation is concerned. Now I'm just asking you some small questions. Just look at the whole, the range you must understand or you must be able to calculate, and try to find out which class your machine belongs to in terms of the IP addresses. So this is the question. Now question is, find the class of each address. This is what the question is. Now A 227, something like this. I'm just ignoring the second one. The B 193. So just read this one. C is dot. Of course, dot is there. 4 octet. 3 other octets are there, which I am not writing. D is 252, and the E is 134. So let's just start with 227. Now let's say this is my first. Now 227. You have okay. Now you tell me. It is D. So now let's verify. D is here. 227 falls here. So definitely, so it comes into the D. Now class B 193.
Sir, it is.
Okay. Is belong to C. Is correct or not? Is correct. So this is belongs to C. Sorry, 193. Now I want new phase now, third time. The C is 14.
Sir, A.
A. Why A? Because the range of A is 0 to 127 and 14 comes here. So this is your A. A. Now 255.
Sir, E.
E. So what is the range of E? Is 255, just at the border is lying. So this way you can do 255. This is your class E. And finally 134. 134 is B, because it is somehow here, right? So this way now most of your machines you will see these addresses, and you can easily identify which class it belongs to. So this is the most important thing you have to understand. Now I told you in the beginning that the your IP address has 3 structure, 3 components. One is class type, second is called net ID. Net ID is the address of the organization which supports now the internet service providers addresses. This is called net ID, or the organization's address now. And then is a host ID, your machine, individual machine's number now. Now again you must know some range again. Of course range can be derived easily from the previous exercise which you have done, but some other way also one can understand what is the size of net ID and what is the size of the host ID. So here in this case the class A net ID Means how big this organization is, basically that way you can see. Class A is net ID is 1 byte and the host ID is 3 bytes. 3 bytes. Now 5 minutes. 5 minutes. Okay. These 3 bytes means that here is that you can organize. What exactly its meaning is? Its meaning is that in this class A, if I have someone, any organizations which has subscribed to this type of class, one can accommodate many machines. How many machines? How many machines? Machine is something, if you can calculate, is 2 to power 24. So many machines one can accommodate with class A. So many different addresses, unique addresses you can have, right? Class B, the net ID is 2 bytes, and the host ID is again 2 bytes. Like this. So this way one is defined. So as you move lower side from class A to class B, you see the size of net ID is increasing and size of host ID is decreasing. Here you have 1, here you have got 2, here you have 3, here you have got 2. So that way people subscribe particular type of this one now. Class C, you have net ID is 3 bytes and the host ID you have 1 byte. And similarly one can understand. So this is basically the range of the how many machines and what is the size of organizations one can support now. The another point which I will just tell you is, you must have heard of or you must be aware of, there is a concept called subnetting, subnet. The many organizations have, you know that, but before that I think since we all have a different background, let me see, sometimes students keep on asking, what is internet, you tell me, whether it's physical entity or whether it's a logical entity, whether it's existing or not existing, and so on. They think that something is not seen, not visible, all types of questions students keep on asking, that what is internet, this type of questions we ask, and this is the reply, that we have not seen what is internet is all about. You all have seen what is internet, it's a physical entity. One way logically, some schematic diagram I will just try to plot to show you that what internet is all about. And most of the organizations have this type of a structure. If I'm just trying to plot my own organizations in network structure here. So there could be the different type of LANs we have, or any organization can have. One could be a Ethernet LAN, just by this diagram. Many departments, organizations have many departments. There is a physics department, there is education department, there is a computer science department, and depending upon the activities they do, they have a different types of networks, and they have multiple networks also. So any organizations like ours have many LANs. And each LANs are of different, it could be of different types. Ethernet, sometimes we call it token ring. There are different type of LAN. We have a wireless LANs. There could be different type of. So one LAN could be this one, another LAN could be this one, third LAN could be this one, fourth LAN could be this one and this one. This is, I'm talking about organizations. Now each LAN, and they have different names, different configurations. Each LAN is connected with large number of machines. Depending upon, they have 30, 40 machines, 60 machines, 70 machines. So each LAN have a number of machines, and this is called host ID, correct? This is called host ID. So, and each one might be connected with another LAN, might be what we'll call them routers. They might be connected. There could be another type of networks here, token rings and so on. So all are connected with this one and something like this. And finally, one of the routers might be connected to the internet. Means is basically internet service providers, gateway like BSNL, MTNL, Satyam, Airtel. Who is your internet service provider? So basically this is the basic structures which we have for the internet. So what internet is? Internet is a large number of networks, and each network connected with the different hosts and so on, and finally they might be connected with the internet service provider, and each device must have a unique ID, a router must have a unique ID and so on. So this is what we discussed. Let me just quickly conceptualize what we discussed is that the different models are there. There is a TCP IP model, there is a OSI model, and the model is different. Of course, there are lots of identical issues are there between the two. We mainly define the IP addressing schemes. We give different notations of the IP, binary notations, hexadecimal notation, decimal notations, and then also we define the different classes. Class A, Class B, Class C, Class D, Class E. We also told that the larger organizations has to go for Class A, and also we gave the structure of this one. What is the range of Class A? What is the range of Class B, Class C? And finally, at the end, we basically made a schematic diagram of internet, which comprises of a large number of networks of different types, given by different vendors, connected with different hosts, running different type of operating systems, and they must have some router connected to the internet service provider. This is what the internet. Now, thank you very much for attending. Thank you. We'll give you enough